Assalamualaikum warahmatullahi wabarakatuh. In this video, we will learn about variables and data types. The learning objectives of these videos are that the student know about variables and data types, and then they know the use of each data types. And also the student know the memory consumption of each data types. And the last objective is that the student know the special features of char data type. What is char data type? We will discuss later. So we start with the introduction of variable. So computer, as its name, comes from the word compute. And in a mathematical sense, the word compute means that we operate a few operands. Therefore, when programmer make a program in computer, it operates those operands. And then we may call those operands as variables. Okay, so in mathematical sense, we call as operands, and in a programming language, we call as variables. And then variable in programming language is actually a place where the programmer can store a value and perform operation. And then the variable in a computer is a memory allocation having a value inside of it. The value inside of a variable must match with the variable's data type. So variable in mathematical sense, it is an operand, and then in our computer, variable is actually a memory allocation, and we can store value to this memory. And what is the value which we can put in this memory? The value which we can put into this memory depend on the data types of that variable. So two things that you have to remember the term in programming are variable, and the second is the data type. So let us see here. The first data type that we want to learn is character. The first data type is char. This is the name of the data type. And char has 1 byte memory allocation. So suppose you have RAM or memory inside of your computer. So suppose this is your memory. The size of each memory will be 1 byte or equal to 8 bit. So if you're using char data type, it will use 1 slot of memory, which the size is 8 bit or 1 byte. Okay, so this is the example. So this is your data type, and this is your variable. So it means that you have a variable with the name A, and then it has 1 byte memory allocation, and the value inside of this is actually 65. So you have to convert this 65 into binary number, and then you can store in this memory. Okay, you have to convert that 65 into a binary number. And then you can store it. But you do not have to do this conversion, because the compiler will convert it. You just put it this 65. And also you can have b as the variable, and the data type is char, and the value inside of it is a. So char means it is character, so a, the alphabetical letter, they are character, and then numerical symbol, they also character. 1 2 3 4, this also can be a character, or it can be number. And also you have some kind like ampersand, and then quotient mark, quote, double quote, single quote, dot, comma, and so on. They are also character. So this char is suitable to store a character, okay, only single character. So you can so if you have a data which consists of one character, it can be symbol, it can be a character like this, or it can be letter, or it can be number. So char data type is the most suitable. So here in the second example, you have b, a variable with the name of b, and then inside of it you have the value of a. So here, what is the difference of the first example and the second example? So actually our computer cannot understand this a value, this capital A value. Our computer only understand number. Okay, so we have to convert this a into a number. So a in our computer will be recognized with the number of 65, this one. So between a and b, they have the same, or they have equal number. So here it will be 65, but it is in the binary form. This is also 65 in binary form. Even though we have two different ways to state the same thing here. Okay, remember that our computer cannot recognize letter or character, however they recognize a number. Okay, so they will convert, or the computer will convert a into a number. We will tell you later the conversion from character into number. So this data type is only 1 byte, so it means that we have 255 characters. We only have 255 characters. So as you can see in your keyboard, there are so many characters there. So all those characters, it can be stored in this 1 byte, in this jar. But the problem is that suppose you live in Arab, or you live in China, you live in Japan, they have their special characters. Suppose like a Chinese character, Arabic character, then Japanese character. They cannot be stored in this 1 byte character, so they need more byte to represent their characters. Okay, so suppose like Japanese character, we can use this char 16 underscore t as the data type, because it is not included in 1 byte characters. The Japanese character is included in 2 byte. Therefore, we use this as our data type for Japanese character, and then this is the variable. The variable is C. So C will use 2 memory allocation because it has 2 byte, like this. And then we store this value. This is the symbol of water in Japanese character. So it will be converted into number, and also it will convert it into binary, and then it will be stored in this memory allocation. Okay, that's the first data type that we have. And then the second data type is integer. We have 1, 2, 3, 4 data types for integer. The first is short. This is only 2 byte. And then integer, this is also 2 byte up to 4 bytes. And then long integer, this is long or long integer, it is 4 bytes, and long it is 8 byte. So suppose you want to store a small value of integer, you just use short because it consumes less memory rather than long. So suppose you have this minus 154. This number is enough to be stored in 2 bytes memory. Therefore, we use short rather than using long. Because if you use long, but you store just a small integer values, then you will waste your memory. Okay. So suppose you have 50,000, then it is better to use integer, int, rather than using long. But if you have a huge integer value, then you can use long data type. Okay, so here you have to choose your data type wisely. If you know that the value that you want to store inside of a variable is small number, then you choose data type with the size with small size. Okay, but if you have big value of data, then you can use a big data type for its size. Okay, we also have unsigned integer, unsigned short, unsigned int, unsigned long, and unsigned long. What is the meaning of unsigned? This unsigned means that it is only non-negative value, so we don't have any negative value. Okay, and then for the decimal number, we can use one of these 3 data types. The first is float. Float is only 4 byte, and then double is 8 byte, and then long double is 10 byte. The same thing as the rule in the integer, you have to be careful when you're choosing your data type. You have to see how many bit precision that you want. Okay, suppose you just need a small decimal precision, small bit precision, then you just use float, because float is 4 byte rather than using double, which is 8 byte. However, if you need high precision decimal number, then you can use double or maybe long double. Okay, so choose the data type based on the necessity of the bit precision. So here, small example of our data types that we have: integer, and then char for the character, and then this is char 16 that we can use Japanese character inside of this, and then this is long integer, TNE, and then unsigned long, and so on. You can see here that for the float, this is float G, the bit precision of G will be in here. So we have G, so this is our H, this is our G. Wait, this one is 0. Okay, this one for the G we have truncation. Yeah, we have a truncation here because the bit precision of the float is limited, so we don't have this decimal values because of the limitation of the size of float data type. And then if we use double, then we can cover all the number, this number, and also the decimal places. This is also when you use long, then you have this number and also the decimal places. So this is the example. When you use float, then it will be only 4 byte. You cannot store more than 4 byte. When you use double, then you can store 8 byte, so more number that you can store. And then for the integer, we have EF. I think, okay, there is no special cases of this integer. However, in this example that we have to see this G, this is a good example that float is only 4 byte, therefore we don't have the decimal places here. And this one precision means that we want to show the decimal places up to 30 digit of precision. So this is 30 digit after the decimal places. However, this 30 is too big. Maybe it's only 20, 15. That's enough. Okay, now what is the rule when we are giving variables name? So variable can have a name which consists of letters, okay, A, B, C, and something like that, and then numbers 1, 2, 3, and so on. And then the only character which is available for variable's name is only underscore, okay, and we can use their combination. The name of the variable cannot be C++ built-in names such as while, for, do. This is built-in name in C++. This name is already used by C++, so that we cannot use this name. And then the name is case sensitive. So suppose you have capital A and small a, that's a different variable. Suppose you have int A and int A, they are different. Okay, so this is the example. We use underscore, and then letters. This is letter and capital letter, letters and number. Okay, we have already see the example of this in the char data type. As I mentioned before, that character in computer is actually stored in number. Okay, so if you have A, computer will recognize this A as 65, integer number of 65. So actually computer will convert this letter into a number based on something. Okay, there is a index, or there is a table which convert this letter or this character into number. The name of the table is ASCII table. So you can look for this, the ASCII table, and then you can see that there are conversion from characters into integer number. So here variable using char as the data type has special feature that it can be an integer values from 0 to 255. So the values of char is only 0 to 255, and inside of this include this 65 or capital A letter. So when we use char as our data type, we can put the value with integer number between 0 to 255, or we can put the value as a character. However, you have to put single quotation mark, so you have to put this. So they are the same. And then, for example, character A is recognized as 65, as this is our previous example. And then you can refer to ASCII table for the complete list. You can download it and you can see the conversion from letter or from characters into number. So now I hope you can answer this quiz. Which data type is suitable for representing decimal having precision up to 10 power of minus 12? So the bit precision is minus 12. You can use double. Or if it is not enough, you can use the long double. However, you will use more memory. Which data type is suitable for representing integer number of this? Okay, maybe long is enough, or if long is not enough, you can use long. Which data type is suitable for representing Chinese letter? You can use char 16T. How does C++ recognize character P? You can see the ASCII table if you have already downloaded, and you have to look for P and see the decimal symbol for P, which is 112, small p. Okay, this is the end of this video, and we will discuss another topic in another video.